Are there any questions over the homework before we start on today's note sheet with solving? We finished up multiplication and division. Homework today. Homework today. Here's 2 and a third. So the stack of 2, pass those back. Yes, I realized after y'all headed out, I forgot to pass those out. So that's the homework sheet for yesterday. And today we're talking about solving rational equations. Now, when we solve rational equations, we deal with something called restrictions, and then we multiply by the least common denominator. Now, our restrictions for any of these here are whatever x value is going to make the denominator be 0. Here, there's only one place where x is in the denominator, and that's our 3x minus 1. So if we want to find the restriction, we set it equal to 0, solve, and that would be our restriction. So here we would add 1 to both sides, telling us 3x is equal to 1. Divide both sides by 3, telling us x cannot equal 1/3. So if we get a solution of 1/3, it will not work for this problem. Any questions on this so far? Now, the next thing we need to do is simplify all the fractions, because if we can get rid of all the fractions, it's going to make it a little bit easier to work with. Now, for the one on the left, if I was to multiply this by 3x minus 1, then this 3x minus 1 in the denominator would cancel out. But if we do it to one side, we have to do it to the other. Now, these would cancel. So we don't have any fractions left on the left-hand side, do we? They're all gone. Do we have any fractions left? We have the 3/4, yes? What do we need to multiply it by? 4. Because here the 4 and 4 would cancel out. So that leaves us with 4 times 6 on the left, and on the right we have 3 times 3x minus 1. Questions on any of this here? Now we can use the distributive property. 4 times 6 is 24. Here we'll distribute the 3. 3 times 3x is 9x. 3 times negative 1 is negative 3. Now we just need to solve for the value of x, so we would add 3 to both sides, telling us that 9x is equal to 27. And lastly, we would divide both sides not by 9, telling us x is equal to 3. Is 3 one of our restrictions? Nope. So that is it. Any questions on this one here? So the least common multiple, or least common denominator is, yep. Least common denominator, least common multiple for these here is what we multiply everything by to get the denominators to cancel. Are you ready for the next one? Okay. So when we look at this one here, I'm going to rewrite it so I have a little more space to write on both sides. What is one thing we'll need to multiply both sides by? X. So we can do it first. So we're going to multiply this side by x and this side by x. Now the one on the left, the x and x would cancel, reducing that fraction, yes? Will the x plus 4 and x simplify? Well, no, they're not the same. So we'll also need to multiply both sides by x minus 4. Because on the right, the x minus 4 and x minus 4 will cancel out. On the left side, we're left with 5 times x minus 4 is equal to 7 times x, which in our case is just 7x. Well, yeah, we'll get back to it. I forgot the restrictions, but we can look at those here in a minute. Questions on this so far? Now, the next thing we can do is distribute the 5. 5 times x is 5x. 5 times negative 4 is negative 20 is equal to 7x. Now, we just need to solve for x. Since x to the first power, we just have x. We just get it by itself. So we would subtract 5x from both sides. Telling us that negative 20 is equal to 2x. And last but not least, we would divide by 2, telling us x is negative 10. Questions on this here? Now, I didn't do the restrictions. And the two restrictions, we had x and x minus 4 in the denominator, yes? And we know they can't equal what? 0. So one of them, x cannot be 0.
Madison Hill and Colton Jones, you need to go to the library at this time. Madison Hill and Colton Jones, go to the library at this time, please.
And if we solve for the other one, it can't be 4. 0 and 4 are the two restrictions for this here. But this one, it doesn't really make a difference because, well, our answer is negative 10. They're not one of our restrictions. Questions on this here? Are you ready for the next one? So this one here, I will remember to do the restrictions first. So x plus 1 and x plus 7 are our two denominators, and neither one of these can be 0. So for the first one, we solve by subtracting 1, telling us x cannot be negative 1. For the other one, we'll subtract 7, telling us x cannot be negative 7. Which means if we get a solution of negative 1 or negative 7, it's going to be one of our restrictions and doesn't work. Questions on any of this so far? Okay. What do we know that we'll need to multiply both sides by to get the fractions to reduce? X plus 1. We're going to multiply everything by x plus 1. Because the one on the left the x plus 1 and x plus 1 will cancel. Are all the fractions simplified? No. What else do we need to multiply everything by? X plus 7. Because here the x plus 7 and x plus 7 would cancel. Now on the left-hand side, our numerator is x plus 3. It's being multiplied by x plus 7. We have these two multiplied together. On the right-hand side, we have 15 times x plus 1, our numerator times x plus 1. Now at this point here, we need to distribute. X times x would be x squared. X times 7 would be plus 7x. Do the same thing with 3. 3 times x is going to be plus 3x. And 3 times 7 is going to be plus 21. Is equal to, here we'll distribute the 15. 15 times x is going to be 15x. And 15 times 1 will be plus 15. Questions on this so far? Now at this point here, we can combine like terms on the left-hand side. So 7x plus 3x can be plus 10x plus 21. So we have a quadratic for this one, yes? X squared. X squared is our quadratic. Anytime we have x or a variable to a power greater than 1, we need to get it equal to 0. We need to move everything to the other side. So the first thing we can do is subtract 15x from both sides. Telling us that we have x squared minus 5x plus 21 is equal to 15. Then we need to move the 15 over. Minus 15 from both sides. This will tell us that we have x squared minus 5x plus 6 is equal to 0. Now at this point here, we can factor this, we could graph it. Either one will work. If we factored it, two sets of parentheses equals 0 because there's not a greatest common factor. There's not a number that we can divide out of all three evenly. Since the 6 is positive, our signs are the same and match the sign of the middle term, which would be negative and negative. Factors of x squared are x and x, because those are the only factors of x squared. And the factors of 6 are 1 and 6 or 2 and 3. Which ones do we want? 2 and 3. And if we check this here, we'd have x times negative 3, which is negative 3x. Negative 2 times x is negative 2x, which does indeed give us negative 5x. Any questions on how we got to this point here? Now we do have two things multiplied together equals 0, so one of them must be 0. So we're saying that either x minus 2 is 0 or x minus 3 is 0. And we can solve. So here we would add 2 to both sides, telling us x is equal to 2. For the other one, the first thing we would do is add 3 to both sides, telling us x is equal to 3. Are either of these two numbers our restrictions? No. I believe our restrictions for negative 1 and negative 7. So, nope. So these two here are our solutions. Any questions on any of this here? We ready for the next one. Now, again, we can look at restrictions first. So we just take the two denominators, or take all the denominators and set them equal to 0. Now, if we did have any that repeated, if we had x 7 plus x shown up more than once, we only need to solve for it once. So here, we can subtract 7 from both sides, telling us that x equals -7 would cause one of the denominators to be 0. So x cannot be -7. For the other one, we can subtract 2 from both sides first, telling us that -x is equal to -2. We can divide both sides by -1, telling us that if we get a value of x that is +2, we would have a denominator that is 0. So x cannot be 2. So if we get a solution that is either 2 or -7, it will not work in this problem. Well, we are going to need to multiply both sides by 2 minus x, because that would cause the denominator on the left to cancel. We'll also need to multiply both sides by 7 plus x, because that will cause the ones on the right to cancel. Any questions on this here? Now what that leaves us with is 12 times 7 plus x is equal to 15 times 2 minus x. At this point here, we can distribute. 12 times 7 is 84, plus 12 times x is 12x. Here we can distribute the 15. 15 times 2 is 30. 15 times -x is -15x. What can we do next? Luckily here we only have x to the first power, so we just need to get the x's together, the numbers together. So we can add 15x to both sides, which will tell us that 84 is equal to 84 plus 27x is equal to 30. Then we would subtract 84 from both sides, telling us that 27x is equal to -54. And last but not least, we would divide both sides by 27. Minus x is equal to -2. Because 54 divided by 27 is 2, but since the 54 was negative, it would be negative. Yes? Is -2 one of our restrictions? Nope. If it had been +2, it would have been. Any questions on any of these here? We good with these here so far? Now this one here, we don't have two fractions on either side, but we're still going to do the same thing. We can first look at restrictions. Which is really just taking the two denominators, setting them equal to 0, and then solving. So here we would add 4 to both sides, telling us x cannot be, or here y cannot be 4. And the other one we would add 3 to both sides, telling us y cannot be positive 3. Because if we have a y value of positive 3 or a y value of positive 4, it would cause there to be a restriction, which would not work. Now, one thing we can multiply everything by is y minus 4. Because here, we're doing the same thing we did on the previous ones. We're wanting the fractions to simplify. We don't want a denominator. In multiplying everything by y minus 4, our first fraction, the denominator, will cancel with it. So the first one doesn't have a fraction anymore. Are all the fractions gone? What else do we need to multiply everything by? So here the y minus 3 and y minus 3 would cancel. The 1 doesn't have a denominator, so we can't cancel anything with it. I mean, it does have a denominator, which is 1, but that really doesn't do anything. Are all the denominators gone? Yes, now we can move on to solving. So the first one, we have 4 times y minus 3. Minus 3 times y minus 4 is equal to 1 times y minus 4 times y minus 3. Because after we finish canceling, we multiply whatever's left with the numerators of each. Questions on this here? Now at this point here, we can distribute. So for the left side, we'll do 4 times y, which is 4y. 4 times negative 3 is negative 12. We'll do the same thing with negative 3. Negative 3 times y is negative 3y. Negative 3 times negative 4, the negative and negative make a plus, 12. Is equal to, here we'll distribute, y times y is y squared. Y times negative 3 is negative 3y. Negative 4 times y is negative 4y. And lastly, negative 4 times negative 3 is plus 12. Any questions on how we got to this point here? Let's combine like terms. On the left-hand side, 4y minus 3y is 1y, yes? Negative 12 plus 12 is 0. So on the left-hand side, all we have is y by itself. On the right-hand side, we'll have y squared because there's no other y squared terms. But negative 3y minus 4y is negative 7y plus 12. We do have a y squared term. We have a variable with a power greater than 1, which means we need to set this equation equal to 0. And to do that, we would minus y from both sides, which tells us 0 is equal to y squared minus 8y plus 12. Any questions on this here? Any questions on how we got to this quadratic? Now at this point here, we could factor, or we can graph it. We factored on the last one, I'll graph it here. Now even though it is y, we can also write this in x, because if we're graphing, we'll do it in terms of x, which just tells us that we have x squared minus 8x plus 12. Yes, same equation, just with x instead of y. And I can hit graph. And what we're looking for are the what values of x that will make the function equal 0, where it'll cross the x-axis. So we go second table to look at the table. And we're looking for where y is 0. And there's two places where y is 0. One of them is at 6, and the other is at 2. So what that tells us is that y is equal to 2, comma 6, 2 or 6. Because we could say it this way, or we could say y is equal to 2, and y is equal to 6. Either one of these is the same answer. And luckily, neither one of those is a restriction, because our restrictions were 3 and 4. Any other questions on this here? Any questions over anything we've done so far? Are you ready for the next one? Now this problem here, it'd be very tempting to want to multiply, because if we forgot about the restrictions, if we went to straight solving it, to multiply everything by x plus 1, x squared plus x, and x. It'd be very tempting to do that. But if we look at the middle term, x squared plus x, can we factor it? Can we factor x squared plus x? How would x squared plus x factor? We can factor out an x, because both of them have an x in common, and we can pull it out. And if we do that, it reduces it from x squared plus x to x times x plus 1, yes? And that is helpful, because if we'd have multiplied it by x plus 1, x, and x squared plus x, we'd have been multiplying every term by an additional x and an additional x plus 1. We would have been multiplying it by more than we need. Any questions on this so far? A lot of these here, if we can factor the denominators, we need to do that first and then go into our solving steps. We haven't had to do that up to this point because every denominator so far has been factored. Now I do want to look at our restrictions first before we get into the solving steps, because the two places where the denominator can be 0 is x and x plus 1. X plus 1 shows up in two different places. We only need to solve for it once. And we do that by minusing 1 from both sides. Minus x cannot be negative 1. Another one, x can't be 0. I have a feeling you all have already started multiplying, because we can multiply everything by x, yes? And what else did y'all multiply by? Because in our farthest left, the x plus 1 and x plus 1 would cancel, leaving us with just 2 times x minus the middle, x and x plus 1 would cancel with the x and x plus 1, leaving us with 1. And in the last one, the x and x would cancel, leaving us with 3 times x plus 1. Questions on this so far? Now the left side is as simplified as it gets, 2x minus 1. The right side, we do need to distribute the 3 first. 3 times x would be 3x. 3 times 1 would be plus 3. Now at this point, we do need to get everything on the same, well, not same side, because do we have a power greater than 1? Do we have an x squared or an x cubed? No. So we want to get x by itself, numbers by themselves. So I can subtract 2x from both sides. Yes? Or we could also subtract 3. We're just moving things from one side to the other. Well, 3x minus 2x is x. Negative 1 minus 3 is negative 4. Is negative 4 one of our restrictions? So our solution is good. It's just negative 4. Questions on this here? Now this here, we don't have to do that in one step. If it helps you to do it in 2, do it in 2. Because we normally do it in 2 steps, just so we can keep all of our terms straight. We don't combine things that aren't supposed to be combined. But if we feel comfortable doing this, you can do it. There's nothing wrong with it. Questions on any of this here? So this here will be the last one we do today, because I'm going to save some of these for Monday. We'll do them Monday to kind of wrap up, because I think we only have like 3 left after this. But looking at this here, are all the denominators factored? Because the first one we have is 5x plus 5 has a greatest common factor of 5 that we can factor out. 5 out of 5x is x, and 5 out of 5 is 1. So we have 5 times x plus 1. How can we factor x plus 2? It's already factored. X plus 2. That brings us to the last one, x squared plus 3x plus 2, yes? What would be nice factors for this here? X plus 1 and x plus 2. Why would I call those nice factors? Yes, because the other two already have it, yes? If it was something else, say x plus 3 was one of these 2 factors, that means I have another term I have to multiply everything through. Yes? Because the 2 fractions that we already have, I'm going to need an x plus 1 for the first one, this one here. I'm going to need an x plus 2 for this one here. So if this last one has only one x plus 1 and one x plus 2, I'm not adding anything to it, because we're already having to multiply everything by it to begin with. But if this adds new factors, that means it's new things that I have to multiply everything by. Does that make sense? Yes. And it does indeed work out that x squared plus 3x plus 2 is x plus 1 times x plus 2. Since the 2 is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of x squared, the only ones we have are x and x. And the only factors of 2 are 1 and 2. And at this point here, we would multiply everything by 5 for sure, because the first one, the 5 and 5 would cancel, but we do have other factors, yes? So the next thing we can multiply everything by is x plus 1. Now on the far left, the x plus 1 and x plus 1 would cancel. The middle, does anything cancel with it? No. And the last one, the x plus 1 and x plus 1 would cancel, yes? Now it seems odd I'm doing this at one step at a time, but I'm doing this to just make sure that I don't go over what I need. And the last one we need is what? The x plus 2, because the one in the middle, the x plus 2 and x plus 2 would cancel. And the last one, the x plus 2 and x plus 2 would cancel. Are the denominators gone? Yeah. And if you feel comfortable doing this, go on and do it all at once. Sometimes doing it one set of factors at a time can help us, just to make sure we don't go above. But if we do have all the denominators simplified, it does make it a little bit easier. Questions on this so far? Now the first one, what we have left in the numerator, well, we just have x times x plus 2 is equal to 1 times 5. 1 times 5 is 5 times x plus 1 plus 5. 1 times 5. Because everything else in the last one canceled out. Do we feel comfortable getting to this point here? We'll start our distributing. X times x is x squared plus x times 2 is 2x. Here, x times 5. 5 times x is 5x. Plus 5 times 1 is plus 5. Before I start moving anything, I want to combine like terms. It's a little bit easier to work with. Our 5 and 5 would combine to give us plus 10. Do we have a variable with the power greater than 1? Get it all to the same side. So we can minus 5x from both sides. What else would we end up minusing from both sides? 10. So we could say x squared minus 3x is equal to 10, and then minus 10 from both sides. Move this up a little bit so we can see it better. Telling us x squared minus 3x minus 10 is equal to 0. Now we could have done that all in one step, or we can do it in two. If you feel better or feel more comfortable doing it in two, do it in two. If you feel comfortable doing it in one, do it in one. It's really up to you guys on which one you're going to choose. Now, we need to solve this here. X squared minus 3x plus 10. What is the likelihood that the solution will be a fraction? What's the likelihood that it will be? 0. Because what's the only way that this can get a fractional solution? Is if the number in front of x squared is not 1. Because if the number in front of x squared is something other than 1, then there's a good chance we'll get a fractional solution. So here, a is 1, which means our solution should be whole numbers, integers, not fractional. Which means I can graph it. Because we have x squared minus 3x plus 10. So, does anybody else spot the error? Minus 10. We have two places it crosses the graph. Second table, negative 2 and 5. So it tells us x is equal to negative 2 or 5. So there's a good chance. Nope, I missed them. X plus 2, not x. Because if we look back at the top, the denominators were x plus 2 and x plus 1. Were our two that we had, yes? And really, restrictions will also be whatever we multiply everything by. Because those are the two places that really the restrictions show up. So if we set x plus 1 equal to 0, we say x cannot be negative 1. We can do the same thing with 2. Minus 2 from both sides, telling us x cannot be negative 2. So that's why negative 2 doesn't work. Questions on any of this here?